Welcome to this video series on frequently asked questions about the Java language. In this ongoing series of videos, we'll answer commonly asked questions about the Java language. You'll come away from this video with a solution to a question that you, as a developer, may have. In fact, these questions have been asked by thousands of developers, so you're not alone. Our approach to every question is simple. First, we pose the question about the Java language, Java development, or best practices. Then we fill in any background material so the question makes sense. Next, we'll get into the details of the question and discuss it further. Then we'll come up with an answer. As a bonus, we'll go deeper on the answer and look at a code example showing you what to do and in some cases what not to do with a counterexample. Stick around until the end of every video where we'll discuss the solution from an application security point of view. We'll let you know what to watch out for to ensure your code stays secure. For more videos like this, like and subscribe to be among the first to know when we release something new. Ready to get started? Let's go. So the question in this video is, let's say we have a primitive double value and we want to convert it to a string. We want to round up the last digit in the fractional part of the number using the standard, if it's greater than 5, round up approach. We only want to see significant digits, meaning we don't want to see any trailing zeros. All right, let's do it. Let's assume that we have a primitive double that looks like the following. Pi equals 3.1415926535. A simple way to perform the operation is to use the java.text.decimal format class. The class gives you complete control over the formatting techniques used and the number of decimal places to specify. We can create an object of type decimal format and specify the format we wish to use as an argument to the constructor. We also have control over the rounding behavior using the setRounding method from the class. Pretty simple stuff. But before we look at the coding example, let's talk for a moment about floating point numbers in Java. Floating points in Java, which include the primitive types float and double, are fine for many operations, but just be aware they introduce rounding errors into numerical calculations. Floating point numbers are binary representations of decimal numbers and thus are simply approximations of the numbers they're attempting to represent. Repeated mathematical operations using decimal numbers can result in some surprisingly inaccurate results. We will illustrate this in the coding section with some eye-opening examples. Fortunately, Java solves this problem for us by providing us with an alternative. The BigDecimal and BigInteger classes are incredibly accurate. Any application that is performing financial calculations should use these classes to prevent the introduction of seriously inaccurate results in any numerical operations performed by the application. Okay, let's switch gears and take a look at some code. For this lesson, we'll be working in IntelliJ IDEA running on a Windows 10 machine. Let's start by creating a class called roundInPlaces. We'll use the IntelliJ shortcut PSVM to create our main method. Let's create a variable, value01, of type double, and assign it with an initial value of 0.7. And let's print out that value. We'll use the SOUF shortcut in IntelliJ and print the value of value01 and add a value of 0.1 to it. And let's run that code. Not good. Just that simple addition statement is already creating inaccuracies. Of course, 0.7 plus 0.1 should be 0.8 instead of 7.999. Knowing that the value is inaccurate, we'll still go ahead and use the decimal format class to print out the result. Let's create a new variable, decimal format of type decimal format. We'll hit Alt-Enter to add the import statement. We'll assign decimal format equal to a new decimal format, invoking the constructor with a pattern of pound.5 pound symbols, meaning we'll have up to 5 decimal places shown. And let's create a printline statement again, and this time invoke the format method of the decimal format class. And let's run that code. When we do, we get back a value of 0.8 for our result. Java didn't suddenly get better at performing additions for doubles. Instead, between the rounding and the formatting, the inaccuracy of the equation is masked from us, even though we know from performing the calculation earlier that it was inaccurate. Now let's create a new double value, pi, and assign it a value of 3.141592. And let's set the rounding mode of decimal format to rounding mode.ceiling. This mode will round towards positive infinity. If the result is positive, it behaves like rounding mode.up, and if the result is negative, it acts like rounding mode.down. This mode never decreases the calculated value. Now let's print out the value of pi using system.out.println. Recall we had 5 decimal places specified previously in the decimal format object we used to print our format statement. When we print the value, we get back a result of 3.1416. Because we don't show trailing zeros, only 4 significant digits are shown. Let's switch gears now and take a look at some code that uses BigDecimal. First, let's comment out the last 2 println statements we created. And let's create a new variable called bd_value01 of type BigDecimal. And we'll assign it a value using the BigDecimal class and passing in 0.7 to the constructor. And let's perform the same calculation we did above and add 0.1 to the value using the add method of the bd_value01 object. A few things to note about the BigDecimal class. First, they're immutable, meaning we cannot change the result, and because Java does not support operator overloading, we have to use methods like add and subtract in place of plus or minus. Now let's add a println statement and print out the result of the addition. We'll highlight it by using a message in front of the value and say bd sum. And now let's run the code. Whoa, what's going on here? BigDecimal doesn't look that hot right now. Notice that in this case, the value returned from BigDecimal is just as bad, if not worse, than the calculation performed with the double values we looked at initially. The problem is that we constructed our BigDecimal values with doubles, which even when used in this context are still approximations and therefore are inaccurate. The inaccuracies carry over to the BigDecimal operations, which can't do anything about the poor approximation of the underlying floating point values used to initialize the BigDecimal values. So what to do? We'll replace the double values with string values instead. Let's go back to the 0.7 double value and replace it with a string representation of the same number. We'll do the same thing for the 0.1 value. And then let's rerun the code. When we do, finally, we get the correct value of 0.8, which is what we would expect. Let's do the same thing now with pi. We'll create a variable called BigPi and assign it a value of 3.141592. We'll set the format to use 4 digits of precision and a rounding mode of ceiling. And print the value out with the println statement. and we'll run the code. When we do, we get the expected value of 3.1416. When it comes to security, are there any concerns when it comes to rounding numbers? Yes, there are several CWEs related to floating point comparisons and numeric errors. Any check that's done in code for equality of floating point numbers will fail, perhaps intermittently. This may cause an application to fail, or at best behave erratically due to inaccuracies of floating point numbers. The net result is an application that is unreliable, and using the knowledge, an attacker could exploit the flaw, causing it to fail, be unavailable, or use the rounding errors to steal small amounts of money, sometimes called a salami attack. This kind of attack was made famous in the movies Superman 3, Sneakers, and of course Office Space. Formatting of data to compensate for the inaccurate results of decimal math can result in the use of classes that are not thread safe. Using any class that is not thread safe in an enterprise application can result in exposure of data to another user session, causing confusion, difficult to identify errors, and possibly exposing personal data to others. Thanks for watching. We hope you enjoyed this video. Please like, subscribe, and share this video with others. To get our free ebook on how to write more secure code, go to www.beginsecuretraining.com. When writing code, remember to always begin secure.